Hi, this video is an introduction to completing the square. What I really want to make sure you get out of this video is not only how to complete the square, but why you're doing what you're doing to complete the square. And what we're going to do is that we're going to build our way up from some basic quadratic equations and get us to a point where we're going to need to complete the square. So the first quadratic equation is x squared equals 25. And if you notice, the x is the only variable that we have in this problem, and it's being squared and it's isolated, it's by itself. So I'm allowed to do the inverse of squaring, which is square rooting. So I'm going to square root both sides of my equation, and I end up getting x equals 5, because the square root of x squared is x and the square root of 25 is 5, since 5 multiplied by 5 is 25. But negative 5 multiplied by itself is also positive 25. Okay, so that means that the answer to this problem is actually plus or minus 5, which means that the solutions in solution set notation are going to be 5 and negative 5. So as we build our way up with our quadratic equations, our next example that we see is the quantity x minus 4 squared equals 25. This is very similar to what we did in the last example. Our perfect square is still isolated, so all I have to do is square root it to get rid of that square. And I know that the square root and the square will cancel each other out, so I'm left over with x minus 4 equals, remember, it's plus or minus 5. Okay, then I can just add 4 to both sides because I'm trying to get this x by itself. So I end up getting x equals 4 plus or minus 5. So if I take 4 and I add 5 to it, I get 9. And if you take 4 and you subtract 5 from it, you'll get negative 1. So that means that my two solutions to this quadratic equation are positive 9 and negative 1. The next example that we're going to look at is x squared plus 6x equals 15. And this looks very different from the last two examples that we did because although we have a perfect square right here, this 6x is not a perfect square, and if I get rid of it on this side and put it on this side, then I'm going to have variables on both sides of my equation, which is going to make it very difficult for me to solve. The whole point of completing the square is to get us to a point where we have a perfect square and it's set equal to some type of a constant, okay? So somehow I need to transform this equation to look like this equation right here. So if you remember this example, x minus 4 quantity squared equals 25, it is in that format of something squared equals some constant. But what I'd like to do is actually really take a look at what this quantity x minus 4 squared really means. So the quantity x minus 4 squared really means the quantity x minus 4 multiplied by the quantity x minus 4. So I'm going to distribute this x through and this negative 4 through, and so when I multiply x by x, I get x squared. When I distribute this x to this negative 4, I end up getting negative 4x. And then when I distribute this 4 to this negative 4 to this x, I get negative 4x. And then when I distribute this negative 4 to this negative 4, I get positive 16. So when you combine your like terms, you end up getting x squared minus 8x plus 16. So if the quantity x minus 4 squared is equal to x squared minus 8x plus 16, which is in standard quadratic form, ax squared plus bx plus c, there are some interesting things that we can conclude about b and about c when our a value is 1. Okay, so if you notice right here, the b value of negative 8 is really twice as large as this value right here. And then this c value is actually the square of this value right here. So really what I could do if I want to figure out some information right here, I could take my b value, which is negative 8, divide it by 2, and I end up getting negative 4. Okay, which again gives us this value in our binomial right here. And then if I take negative 4 and I square it, I will end up getting 16, which is the c value right here. Okay, so this is where we start to complete the square. So essentially, when I'm completing the square, what I'm trying to do is I'm trying to take this expression and convert it into a perfect square trinomial. So that way, when I'm done with this problem, I've got something, a whole entire quantity squared, or something where I multiply it by itself will give me this new expression that I'm going to figure out what it's going to be. So I know for a fact that this has to be x and this has to be x, because x times x gives me this x squared. And then I also know that if I were to add these two values together, it would give me this 10, and these two values have to be the same number. So in order to figure out that value, all I have to do is take the b value right here, and I'm going to cut it in half. So I get 5. So I know for a fact that this should be positive 5 and positive 5, okay? And I also know that if I were to multiply this 5 by this 5 right here, if I were to multiply these guys together, I would end up getting 25. And that's the missing value right here that I need in order to make this a perfect square trinomial. So the missing value that I have to add on to complete my perfect square, and that's why it's called completing the square, is 25. Okay, and the way you can figure this out generally is to just take your b value, cut it in half, and then square it, and that value is 25. And then when I want to take this expression and factor it into this right here, all I have to do is either square root the c value or take the b value and cut it in half. Either way, it will give me the same value. But remember, when you square root 25, you could get positive 5 or negative 5. But I know for a fact it's positive 5 because when I double it, I get positive 10. So that's how I end up getting this x plus 5 quantity, x plus 5 squared. Okay? All right, let's go back and revisit x squared plus 6x equals 16, this equation right here. And we notice right here that there's some space missing here because this is not a perfect square trinomial, but if we add something on, we can make it our perfect square trinomial. So how do we do that? Well, again, remember, all you have to do is take the b value, cut it in half, and then square it. So you end up getting right here 3 squared, which is 9. So if I add 9 on to my equation right here, now I have my perfect square trinomial. But remember, whatever you do to one side of your equation, you need to balance it out by doing it to the other side. So I'm going to add 9 to the right side. So this is now right here a perfect square trinomial. But we have to figure out how do we put it as a perfect square so we can go ahead and solve it like those more basic equations that we had at the beginning of the video. So it's going to look something like this, and I know that the first term in my binomial, when I multiply it by itself, gives me x squared. So x, when you square it, gives you x squared. And I know that the last term in my binomial, when I square it, will give me 9, but when I double it, will give me 6. So that value has to be positive 3. So this should be a positive 3 right here, and it is not a coincidence that it is this value right here. Okay, and then just combine your like terms on the right side of your equation, so you end up getting 25. Now I've gotten to a point where I can have a perfect square that's isolated by itself, so square root both sides, you end up getting x plus 3 equals plus or minus 5. Okay, subtract the 3 from both sides, you end up getting x equals negative 3 plus or minus 5. So that means that your two answers will end up being negative 3 plus 5, which is 2, or negative 3 minus 5, which is negative 8. Okay, so that means that your solution to this quadratic equation that we originally had is 2, negative 8. All right, since this was an introduction to an in-depth topic, You may want to watch some follow-up videos to see some more complicated examples of what it looks like to solve a quadratic equation by completing the square, especially when you have some irrational answers. All right, thank you for watching.